Hello dear students, in this video we are going to study the partial differentiation, basic concept of partial differentiation. Myself Professor Vaishali Bharat Gholak. See, differentiation, this we have already studied. In this case we try to find out the rate of change on this curvature. Okay, you know that the rate of change or slope on each and every point on this curve is different. So we find out the rate of change on at some single point. Okay, that point we call it that point is AB, and we find out the rate of change on tangent line. Here y is a function of x, and we represent that differentiation is derivative of f of x with respect to x is equal to limit h tends to 0 f of x plus h minus f of x upon h. This is a simple derivative. Now, if we want to find out the derivative with respect to another variables or more than one variable, then here comes partial differentiation. For that purpose, we need to understand partial differentiation. Okay, and notation for that partial differentiation is curvy d. You can see here. This is a simple derivative. Here we represent derivative with respect to x as a d, small d. But in case of partial differentiation, we represent d as a curvy d instead of regular 1d. Okay, and that we call it as a partial derivative. A partial, if we want to find out the rate of change for some surface in this space rather than curve, at that time we can, how we can interpret, with the help of partial differentiation. Okay, if we want to find out the rate of change in x direction, much like we have been already studied, we simply differentiate with respect to x. In this case, we treat y as a constant. And if we want to find out the rate of change in y direction, at that time we find out the derivative with respect to y and we treat x as a constant. This function is function of x and y. That's why we need to use or calculate the partial integration. Okay, partial derivative of function with respect to x taking y as a constant we represent as partial derivative of function with respect to x is equal to limit h tends to 0 f of x plus h comma y minus f of xy upon h. This is a partial derivative of function with respect to x. Here we treat x, y as a constant. Then partial derivative of function with respect to y, here we take x as a constant. The partial derivative of function with respect to y is equal to limit h tends to 0 f of x, here y plus h, because here we want to find out rate of change along y direction or along y variables, minus f of x y upon h. This is the basic concept of partial derivative or partial differentiation. Just recall the previous studied standard functions derivative. Derivative of constant is 0. Derivative of x raised to n is nx raised to n minus 1. Derivative of x is 1. Derivative of e raised to x is e raised to x. Derivative of a raised to x is a raised to x log a. But condition is a should be more than 0. Derivative of sin x is cos x. Derivative of cos x is minus sin x. Derivative of tan x is sec square x. Derivative of cot x is minus cos x square x. Derivative of sec x is sec x tan x. Derivative of cos x is equal to minus cos x cot x. Derivative of log x is 1 upon x. These are the some standard functions derivative. Now we are going to solve some simple problems. Determine the partial derivative of function f of xy is equal to 3x plus 4y. What is the given function? Given function is 3x plus 4y. Now first we need to find out the differentiation with respect to x. Here we consider y constant. Partial differentiation of function with respect to x is equal to 3x. Here 3, why we bring outside? Because 3 is a constant. 3 partial derivative of x with respect to x plus 4 is a constant. That's why we bring outside of the derivative partial derivative of y with respect to x. Now see, derivative of x is 1. That's why 3 into 1 plus 4. Derivative of y is 0. Why? Because here we find out the partial derivative of function with respect to x. Means we treat y as a constant. And derivative of constant is 0. That's why partial derivative of this given function with respect to x is 3. Now to find out the partial derivative with respect to y, here we keep x as a constant. Partial derivative of function with respect to y is equal to 3 as a constant. That's why we bring outside partial derivative of x with respect to y plus 4 the partial derivative of y with respect to y. Here, the partial derivative of x with respect to y is constant. Why? Because here x is a constant. We treat x as a constant. 3 into 0 plus 4 into derivative of y with respect to y is 1 is equal to 4. Next problem. Determine the partial derivative of function f of xy is equal to x square plus 3xy. Okay, given function is x square plus 3xy. First we find out the partial derivative with respect to x. Partial derivative x square plus 3y. Why we bring 3y outside? Because when we differentiating with respect to x, we treat y as a constant and this y is with x. That's why we bring outside 3y. Derivative of x with respect to x. Partial derivative of x with respect to x is equal to derivative of 2x is 2x plus 3y into 1. 1 is a derivative of x with respect to x, which is equal to 2x plus 3y. Now, we need to find out the partial derivative with respect to y, keeping x as a constant. Derivative of x square with respect, partial derivative of x square with respect to y plus 3x. Why bring 3x outside? Here we finding the partial derivative with respect to y means we treating x as a constant. This x is multiply with y means we have to bring outside the partial derivative sign. 3x into partial derivative of y with respect to y is equal to x square, as x is a constant, 0. Partial derivative of x square is 0 plus 3x into partial derivative of y with respect to y is 1. That's why partial derivative with respect to y is 3x. Next problem. Determine the partial derivative of function f of xy is equal to xy square plus x cube. Given function is xy square plus x cube. First we find out the partial derivative with respect to x. Here we keep y as a constant. Xy square derivative. Here we have finding the partial derivative with respect to x means we treat y square as a constant. Y square partial derivative of x with respect to x plus partial derivative x cube with respect to x is y square plus 3x square. And then partial derivative with respect to y is, here we treat x as a constant. Partial derivative of xy square with respect to y plus partial derivative of x cube with respect to y is, here we treat x as a constant, x bring outside, partial derivative of y square with respect to y is 2y, means partial derivative is 2xy plus 0. Why 0? Here when we finding the partial derivative with respect to y, we treat x as a constant and derivative of constant is 0. That's why partial derivative with respect to y is 2xy. Next problem. Determine the partial derivative of function f of xy is equal to x square plus y square plus x square y square. First, we need to find out the partial derivative with respect to x. We keep y as a constant. Partial derivative x square with respect to x plus partial derivative y square with respect to x plus partial derivative x square y square with respect to x is 2x plus 0 plus y square 2x. This is the partial derivative. Then partial derivative with respect to y, we treat x as a constant, that is 2y plus 2y x square. This is some example of partial derivative of the function x and y. Thank you.